Good evening, everybody, and welcome to today's presentation with Nuge. Just as before, we have a few slides about us and what the agenda is, and then we'll get on with the presentations. Let's see. Yeah, about Nuge. As you know, we are part of the .NET Foundation, which means that we are by developers for developers, and we focus on talks where presenters have practical experience of the things they talk about. Here is some information about where we can be found on Twitter, YouTube, Twitch. We're always interested in hearing from you, so please just reach out on, yeah, here you can contact us by email or just reach out to any one of us. We also have this YouTube channel, so subscribe, like, and I don't know, click the notification bell. Isn't that what they say? And as always, thanks to our sponsors, Beck, Bouvet, Forsa, Making Waves, Miles, and Microsoft. They make these arrangements possible. And who we are. This is the board members, lovely group of 8 people. You can reach out to any one of us if you have anything you want to present. And the new things is this questionnaire. We would always like to improve ourselves and make the best content possible. So if you click this link, which we will also be posting on Twitch and YouTube, I believe, you can give us input on what you would like to hear more of, and if there are any topics or themes you would like to hear. We also have a winner of the best tech question, and they will receive a swag pack from Microsoft to home address. So just keep posting comments, and we will read them out loud and get the answers from our presenters. Yes, and tonight's presenters are Sara from Microsoft and Sergey. Sara will talk about continuous delivery at scale, and Sergey will present the .NET Core Workers services in production. The agenda is like this. This presentation from me, 5 minutes or so. Then 25 minutes presentation from Sara, and 5 minutes Q&A. Then we move on to Sergey and finish off with questions for Sergey as well. But you can continue to ask questions for Sara throughout the presentation tonight. They will both be here at the end. Yes. Then I will welcome Sara.
Hi, thank you.
Yeah. Thank you. You can you can just tell me a little bit about yourself and what you will present, and the floor is yours.
Great, thank you. Yeah, so my name is Sara Bergman. I am a software engineer at Microsoft Development Center in Norway, here in Oslo. I am actually Swedish though, but I've lived here for 2 years now, which means I'm fully fluent in svorsk, which is the weird combination of Swedish and Norwegian where no one fully understands you, but everyone sort of understands you. So I will spare you of that and speak English. Yes. So what will I be talking about today? Yeah. So I will be talking about continuous delivery at scale, basically because my team has a very big service, and continuous delivery is a bit complicated by that fact. So hopefully by the end of this talk, you will have some actionable advice if you also have a larger service. All right. Thanks. Cool. It's great to be here and speaking to you all. I've done quite a few of these digital talks now this year. It never stops being kind of weird, but it gets slightly less weird every time. There will be a Q&A at the end, like Ragnhild said. So if you have any questions, please just fire away. Like I said, I work at Microsoft. I'm a software engineer. But why am I talking about massive scale? Right, so I am a software engineer. Like I said, I work in a team called People Services, and we are an infrastructure team, and we backend mostly. And we provide people profiles and profile images for both consumer, educational, and enterprise users. We have a series of APIs, and several of them are not only used internally within Microsoft, but they're also available through Microsoft Graph. If you've never heard of it, this is the URL, and this is one of the queries to one of our APIs. And this basically allows third-party users to also develop against our APIs, which I think is a very fun part of my job. So what else do we use? Here I put some of the user-facing application that we serve. So as you can see, it's quite a wide array of both mobile applications like Outlook, but also Edge, OneDrive for both consumer and enterprise, the Office apps like PowerPoint, which I'm currently using, also Teams and Teams for consumer, which is kind of new, which is fun. So there are also several more. I just put on a few of display. So if you ever seen your name or your image in one of those applications, that was from my team. Our services have over 1 billion monthly active users, unique active users, and the services are run on thousands of machines across the globe. So that to me makes it truly massive scale. Okay, continuous delivery at scale. What does it really mean? I think we need to debunk this in a few steps to make sure we are on the same page. So firstly, what is continuous delivery if you never heard of it? Well, it can be summarized as the ability to get changes of all types that can be including new features, configuration changes, bug fixes, or experiments into production, so really into the hands of your users safely, quickly, and in a sustainable way. And I've been talking a lot lately about sustainability as carbon, and that's not what I mean here. I mean sustainable as the team, the work pace and the work methodology of the team is sustainable over a long time. We don't want to have like a hackathon feeling. While that can be fun, pulling an all-nighter is not sustainable in the long run. All right, so maybe this sounds easy. Yeah, of course, getting new changes to the hands of our users fast. How hard can it be? And perhaps it's not that complicated everywhere. But it can also be very, very complicated. But what's important here is that if we do it right, we can reduce both the cost, the time, and also the risk of delivering changes. And this can be used to build a foundation of rapid experimentation and innovation and unlock great customer value. So that was the first part. What about when you start talking about truly massive scale? Does that mean anything else? Does the challenge change then? We need further unpacking. What do we mean by massive scale? It can really be anything, right? Or can it? So I've listed 3 different things here. Is it how many machines your service run on? Is it the number of contributors your project have? Or is it the number and variety of users? Well, I think it can be any of these, and I think it can also be all of them together or only a subset. For example, I can use the open source project, the Linux kernel, because if you think of a Linux system, it really only runs on one machine at a time. And if I may say so, it caters to a specific kind of user, so there's perhaps not a huge variety of types of users. But the massive scale of the Linux project really comes from the number of contributors that the project has had over the years. I looked up some data, and in 2017, so that's 3 years ago now, there was over 15,000 developers that had contributed. And yeah, that was 3 years ago, so I'm sure it's a lot more now. But in my day-to-day life as an engineer at Microsoft, I have all three of these. And what's interesting is that when the scale of your service goes up, so does the complexity of your solution. When you have a smaller system, there are really a lot of edge cases that are edge cases, and you don't really have to consider them. You can abstract them away or sort of ignore them. But in a very large system, all of a sudden those edge cases aren't edge cases anymore. They are valid use cases, which we have to engineer for from the beginning. And doing that while staying agile, fast moving, and continuously delivering, well, that's a truly delightful problem. So what we need is a number of tools in our tool belt to be able to handle these scenarios. And I thought first I show you an example of what one of those edge cases that's an actual use case for us can be. So you might be thinking now, why does the number of machines really matter? Don't you have a distributed system? Yes, the system I work with and the service I work with is a distributed system, and there also isn't that much of a need for communication between machines. Sounds pretty easy. We're also like a one-hit service, meaning that we get a request saying Outlook Mobile is like, hey, give me the image of this user. And we say, okay, here is the image. And then it's sort of done. So once again, that sounds pretty easy, right? Where's the complex scenarios in this? But ponder this scenario. So you have a massive service and you have massive load. And all of a sudden, you need to take a new dependency on some different system. And they are not distributed. Perhaps it's a new legal requirement, and the service is like just starting to be implemented, so it's fairly new. Or maybe it's a legacy system, and because it's legacy, no one wants to invest in making it like super great. They have something and it's like good enough. But with your massive service, you can't just ponder it down. So you decide to be mindful of this service. We don't kill servers with friendly fire here. So you say, okay, we're not going to call this service for every user. It's enough. It suffices the legal requirement or whatever requirement if we only do this every second day. So we will just call this centralized service every 48 hours for every user or every machine, whatever, because we don't want to take it down. So you test this for one machine, and it works fine, smooth sailing. But then you decide to deploy your change to all of your machines, but there is no staggered start. And all of a sudden, all those machines says, hey, I apparently need to sync with this system, and I've never done that before, so I better hurry up and do it right away. And that's how you take a centralized service down, which is not very great. So how could we have avoided this situation? Well, we did something right. We tested this in production. But we only did it for one machine and then all of them. When you're testing in production, you may want to consider doing that in increments. So if you have servers, you may call this risks or rings or environments or blobs or whatever. If you have like user-owned devices like phones or laptop, you call this maybe batches or A/B testing or whatever. But the important thing is that you sort of go step by step and evaluate as you go. And the balance here is to get real customer feedback, because your customers are going to be able to give you the best feedback and the best testing of whatever it is you're trying to test. But you also want the risk to be low, and you also want to move you don't want to move at like a glacier pace. We're trying to be continuously delivering. So that's something to consider. Another thing to consider is automated rollbacks, because that sounds really great, right? Something breaks, we see that the build is bad for whatever reason, and then our system takes care of that for us and rolls back. And that's really good, but it's important to don't fall into a cycle where you're continuously rolling back, so you're end up getting slowed down that way. So you need to be very specific about which criteria you actually roll back for. What's serious enough so that we roll back everything, because maybe you deploy like several changes at a time. So you have like a group of changes and one of them is very critical and then another one is bad. Then you sort of want to have a way of determining like how much risk can we handle, and that should not be decided when your service is burning. That should be decided before. Also, these criteria need to update. Services are continuously evolving, right? We're continuously delivering, so they're continuously getting improved. And that means that your criteria also need to change when the system changes. If you remove a feature or add a feature, it needs to be covered or that criteria needs to be removed. Okay, so this sort of covers the first part, how we deal with a large number of machines. What about this second one, how to deal with a large number of contributors? I often say that software development is the world's largest team sport, except there are no Olympics, to my parents' disappointment. But that's okay. Dealing with a large number of contributors is another factor that is going to affect your continuous delivery process, whether you like it or not. So working for Microsoft really means that you get to work with people from all sorts of different teams from all over the world. So my closest colleagues sit, except for here in Norway, they also sit in the US, in Czech Republic, in the UK, in India, and they're also much more starting up in Africa as well. So they're really spread out. There are also a lot of different types of teams. We work with designer team, front-end teams, AI or intelligence teams, architect teams, or of course other back-end teams. So there is like this wide plethora of different people that you get to work with. And of course, there are some potential gains from this, right? If you have an on-call service, like you have a service that needs to be up at all times, so you have someone that needs to be on call in case it goes down, what you can do is follow the sun. So someone who's actually awake at their laptop already sort of, had their first cup of coffee or whatever, they will get the call saying something is burning, and not someone who's like sleeping and can't find their phone or whatever, which is good. There can also be less clashes if you have a shared build or deployment pipeline, simply because you're spread out over the day. So when another team is rolling something, it doesn't matter to us because we are not rolling anything anyway. Something I also think is very important is you get a diverse set of perspectives and ideas, because research shows that if you have a more diverse team, you will be like your service or your product will be more profitable. The last one is the question marks. Faster development cycles, right? You have a lot of more people. Surely you can bang out code more quickly because you're just more hands, more minds thinking on the same thing, right? But that's really only true if your code base and your development tools can support it. More people doesn't necessarily mean you're going to go faster. If you have a code base that's really outdated, it's not modularized, it's just going to be harder when you're more people. And the same if you have old or bad deployment tools where you end up stepping on each other's toes all the time, then more people are actually going to mean that you move slower. So potential risks then. Well, I did say less clashes in a shared build or deployment pipeline because builds roll at night, but also builds rolling at night for like a downstream or upstream partner that may affect your service. And if they don't have the expertise to understand what went wrong in your service and how to fix it, they're going to have to call you at nighttime anyway, which is not that fun, right? Collaboration across time zones is challenging. So between the headquarters, where we have a lot of colleagues, it's a 9-hour time difference. We have basically 0 hours overlap. And that means turnaround times for emails, setting up meetings is going to be harder, and it needs to be both sides who give a little. Maybe they need to wake up a little bit earlier, and we need to work a little bit later. And that's something that needs to be worked on and continuously thought about. And if you're starting to get 3 time zones, so you're trying to have a meeting with Oslo, India, and Seattle, well, I can tell you that that's very hard. So that's going to be a bit more challenging, and it requires some innovative thinking. Like, when do you actually need to have a meeting? When is it enough to just write an email or a document and collaborate on that? So there are a lot of rewards, but it needs to be done properly. And yes, this one is on both sides. If you have a shared build or deployment pipeline, things can get messy very quickly. And especially if you are a lot of people, you need to have sort of strict rules maybe for who can do what when. And then you end up haltering how fast you can go. So this is not a situation you really want to be in, because it's eventually going to slow you down and halter innovation. Okay, so the third one, how to deal with a large number of users and a high variety of users. So the Microsoft mission statement is to empower every person and every organization on the planet to achieve more. And to me, the key here is really every person, and I think that's very bold. And this is also going to be yet another thing that can affect your continuous delivery pipeline. Because how do you design a service for every person on the planet? Well, when you talk about everyone, you're going to really have to get serious about everyone. That means people who are visually impaired, people who can't hear or are deaf, people perhaps missing limbs, all sort of neuro variations, all sorts of, like, if you're building a physical thing, like all shapes and sizes. So you're going to have to think about that edge case. It's not an edge case, but it's actually a use case. We're not trying to build like a fighter pilot plane that only, fits people between a certain weight and height range. We're trying to build something for everyone here. What that means is that accessibility is going to be key. And here we can really make use of good cross-team collaboration. We just talked about, we have all these different teams, all these different people, and we can really make that work in a good way here. And even though you might not be working on a user-facing application, I mean, this is a .NET user group. I'm assuming there are at least several of you working backend only, and you're thinking like, accessibility doesn't really matter to me, right? I don't design a web page, maybe. I don't really see the end user all that much. Isn't that sort of the front end team's consideration? And yeah, they have a bigger burden. That's true, and the UI team especially. But you cannot forget about this anyway, because it is so much easier to design with accessibility in mind from the start than trying to build your entire service and then like trying to plug accessibility into it later. So talk to your local experts, join forces with your UI team, and sort of start there. We actually had a good experience where there was a member of the Norwegian Blindeforbund who came and showed us how he used Microsoft software as a blind person. And that was really eye-opening. So if you can do something similar with actual user testing, that's really good, because then you're going to really see the struggles. And it's not really fair that it takes him 10 times as long to reply to an email than it does for me. It's just as important for him to be able to communicate via email or email that it is for me. All right, so the second thing here is that representation really matter. So I think one of the horror stories of this maybe are when like face IDs used to, or started to become a thing. Like all these different companies, they wanted you to be able to unlock your device, your phone, your laptop, whatever, with your face. And it's like a good idea, right? It feels very secure. You always bring your face with you, so nothing you can really lose. But they it really only worked well for white men. Like anyone who wasn't, it was like so. And that was because they didn't have enough diverse training data. And I am convinced that this was not because they wanted to be this way or they were like evil people. No, it just didn't cross their mind probably. No one said, hey, you know what? How do we make sure we have a diverse set of test data? And just having that person who or being that person who asked that question can really have a meaningful impact to a wide variety of your users. So what you want to do here is really design a solution for the world. And if you can have representation from the world in your team, it's going to be a little bit easier. The third one is to embrace users of all different levels of technical skills. Old and not that technically skilled users are just as worthy of our time as digital natives. So my little sister, for example, she grew up as a digital native. She can't remember a time before internet. She uses apps like with ease. But then she may want to use an app to communicate with our grandma. She was not a digital native. She is rather old, and she got her first like tablet, I don't know, 2 years ago. And it's been hard for her to learn and how to use it, but it's such an integrated part of the world that she felt she was missing out if she didn't have access to like apps and that type of communication. But it can be hard to design for both, right? My sister and my grandma, they're very different people. They have very different skill set, very different experiences, and like ease of use. So here we can also make use of some of the tools we talked about, like on the first category, which is testing in production, like A/B testing. Because it's going to be very hard for us, like most of us developers, we are pretty tech savvy. Like it's not, I haven't ever bumped into a person who say, you know, I'm a developer, but I find technology really, really hard. They might not like all technology, but they're usually fairly comfortable using it. So it can be hard to like get into that mindset. So if you can get your service or your product into the hands of actual users, whether that is through testing in production or inviting people to your office. Maybe now don't invite people to your office, but in the future, let's hope we can invite people back to our offices and actually see how they are using our software and make some observation and learn from them. Because then you can see what flies and what doesn't fly. All right, why is this important? So scale is pretty cool. It's pretty cool to say I have over 1 billion monthly active users, but it doesn't mean anything on its own. Like it doesn't have inherent value just because it's a lot of something. What we really want is impact. Like we want to use that scale for something positive, for something good, to have a meaningful impact on people's life, whether there is to make them be able to do their work faster, more effective, or whatever problem you're trying to solve. So continuous delivery can really enable innovation. And that's why it's so important. Like doesn't mean that much. Yeah, it can make your life a bit easier, but the end goal here is that if you have both scale and innovation, you can really have that impact. All right. Thank you so much for paying attention and following along. And now we have time for some questions.
Yeah, so Håkon has one question. I think was related to the pros and cons on the second slide, section. Are the largest challenges technical or organizational?
Very good question. I think that's going to be different for every company. But in the end, there are a lot of great technology out there. There is a lot of research. So I typically tend to lean towards the challenges being organizational, that if that's your team who's not that used to, we want to do it the old way. This is the way we've always been doing it. Why do we need to change anything? It can be hard. But also the wider set, like Microsoft is a fairly old company, and even though we're innovating a lot, like we have a legacy that we can't really escape from that, and I'm sure that's true for many companies, whatever that legacy is. but I'm sure it's there organizational wise. So convincing people that this is the right idea, I think it's generally going to be the hardest, especially because you can sometimes pay a lot at first to then pay less over time. And then people tend to see the short-term cost and like, oh no, I rather continue to move slow, but like at a steady pace. So having some good arguments in your pocket is always a good idea.
And another question was, which tools would you recommend for A/B testing?
Oh, that's a good idea. I don't actually work on a like front-end application. So what you would use for like an app, for example, I'm not an expert in, I'm sorry to say. But for backend, that's going to be entirely also on your solution. But can you find a way where you can, in your code, like toggle switch through flighting maybe? Or can you deploy to only a set of machines? It's going to be very depending on your service as a whole. Might be not that good of an answer, but yeah, I don't have that much experience with front end, I'm afraid.
Mm-hmm. You and me both. That were the two questions. But if the people watching have any more, they can just tag Sara, I guess, in a comment, and we can take it at the end.
Yeah, I'll stick around. Thank you.
Thank you so much. And now over to Sergey. You can just take the wheel when you're ready.
Yes. Hello everybody, and welcome to my home office. This is me. My name is Sergey, and I am a senior .NET developer at Novenet. I'm blogger, occasionally speaker, and pretty active in the social media, so feel free to contact me. Today we are going to talk about .NET Worker services. What is that and why should you care about it? .NET Worker services are, if you have any tasks or any jobs you have to do periodically, like once per day or once per week or once per month, without any human interactions, then the Worker service is a perfect match for you. As you probably know, .NET Core are cross-platform. So you can run this on Linux box, on Mac, or Windows box. It's works just perfect on any operating system. Everything I am going to talk about today will be documented in my blog. And to find my blog, just open your favorite browser, navigate to the sergey.net.com, find tags, .NET Worker Service, and here you can find all my blog posts I already written about Worker Services. Here at the bottom I have one kind of home page for the whole blog series about Worker Services, with all links to the blog posts I have already created. Okay, let's dive into the code. I'm using Visual Studio 2019 preview. Let's launch it. Create new project. search for soon. Search for Voca service. Next. Then we just leave it as default. Click on create. Here we have all .NET installed. I'm just using the latest one and click on create. Now Visual Studio will take a couple of seconds to create the template. I'm going to show you Voca service template as it is and explain it a little bit, how it looks like. So here we go. If you have worked with the .NET Core, this will be very familiar and very easy to start with. We have app settings JSON file. In this file, you put all your configuration values like connection strings, Azure Service Bus connection strings, whatever. Here we have a program file. And I'm going to do something totally crazy and just select namespace, program, main, and just delete it like this. Delete public and delete this. Format it using statement. And just run it. Kind of amazing, but cool. No program, no main, nothing. Just function. All .NET Core programs starts as a console application. And here we are actually converting the console application into .NET Voca service. And it's working. Let's take a look at the Voca class. Voca class is our entry point and has background service as base class. This class has 3 methods to override: start async, stop async, and execute async. In the template, we are just using execute async. We are doing nothing actually here, just logging one sentence, that's it, and sleep for 1 second. Let's take a look at the project file. Project file looks like this. We are targeting the .NET 5 and we have pre-installed one NuGet package. That's it. It's very, very easy and very easy to start with. Now when we understand a little bit how template looks like, let's take a look at some real-life user cases. And we start with messaging. I have created Azure Service Bus in my Azure portal, and I am going to use Service Bus Explorer. I have created 2 topics. This one I'm going to use to send messages to Voca service, and this one Voca service will use to send the message to this topic. To work with Azure Service Bus, you have to install one NuGet package. Microsoft Azure Service Bus. Then you have to define some variables in the app settings JSON. Take a look that I don't have any connection strings here really, because this one, Azure continuous integration, continuous deployment, will replace all these variables for me depending on the environment I want to deploy these applications to. The only one thing I have to mention: when you on the development, all developers has own Azure Service Bus, and to pretend to change app settings JSON file every time, we create normally app settings.local JSON file, and this file actually includes all our secrets like connection strings, shared keys, and stuff like this. To tell the framework to use this local file, you have one file here, launch settings JSON. Here you're saying that use local JSON file. And you have to do one more thing. You have to tell to Git to ignore this file. We don't keep any secrets in source control. So just 2 lines of code, and this file is ignored. As you can see, this red dot here. Now take a look at the worker class. Worker class, now we are implementing all this, we are overriding all these 3 methods: start async, execute async, and stop async. I think it's also best practice to log always when you start application and when you stop application. In the execute async, we are just sleeping for infinitely by using this syntax. And here, take a look how we are using dependency injection. Dependency injection is there for you in .NET Core. You don't have to install any NuGet packages at all. The only thing you have to do is to register in the program CS file like this. So here I'm injecting this message service, and take a look at this function, start listen. To listen for the messages, we have to create subscription client. And here we are using another pattern called options pattern. To use this pattern, we again take a look at the upsettings local. We have these variables. Then we have to create one class. I call it messaging options. And this class has one variable called messaging. I called it messaging, but this value has to match completely with this section in the upsettings file. And then you have properties like this. And then you have to tell to the framework to kind of map this upsettings messaging section into messaging options by this line of code. And then you can use it easily like I'm using it here. Just using dependency injection again and inject these options into the constructor and use it like this. To listen for the messages, I need connection string, topic name, and subscription name. And also I have to provide the function name, which will be called when the message is received. And when the message is received, I'm just deserializing it using JSON serializer from .NET Core. I don't have to use Newtonsoft anymore. And here we are using domain-driven design. When we receive the message, we deserialize it into order DTO object, not directly into our domain model. And this is very, very important because we don't have any control over these messages. It's coming from kind of external applications. Then when we deserialize it into order DTO, we are using automapper to convert it from DTO into our domain model. And to use automapper is also very, very easy. You just install the NuGet package, and then in the program you have to tell to the framework to use it like this. And that's it. And you just use it. Here you have to inject it like this in the constructor again. And one line of code. And again, you have to create, of course, profile, how you want to convert these objects from order to order DTO and from order DTO into the order, like this. Here I'm just using some simple objects. And by one line of code, I get my domain model. And I'm just simulating the saving. I'm doing nothing actually, but just normally you just save it or do something, whatever your business logic is. And now take a look at the send message service. I'm also using dependency injections here. To send the message, I have to define topic client, and here also using this options pattern, again the same way, creating the topic client. Here I am simulating that I'm getting the order from any kind of database or wherever. Here I'm just hard-coded it. I'm creating one object order, hello from worker service, serialize it into the DTO. No, I'm mapping to into DTO, serialize it, and send the message using this topic client. So let's take a look how it looks like in the service bus. So I started the application. So you see application started. So I'm open Service Bus Explorer and send the message on the topic. I prepared one small message here. Start. Here you see the message is sent, parsed, and our worker service sent message back here. Let's take a look at this message. And this is hello from worker service. So it works like this. Now, let's take a look at another user case. File watcher, a file system watcher. Sometimes you need to watch one folder for any changes. For example, we want to watch file watcher demo folder. Let's take a look at this folder. Delete everything from here. So now it's empty. Let's take a look at the worker. What are we doing here? Here we are again implementing overriding start async, execute async, and stop async, as I explained previously. Here I'm using dependency injection again to create file watcher service, and we take a look at the stopwatch method. The only interesting part here is like when anything is changed, when the file is copied, I want to onChange event triggered like this. And here I'm just to create some kind of logic. I'm just expecting one CSV file, and I'm using CSV helper to parse this file. So let's take a look how to use this CSV helper. We are installing CSV helper as NuGet package. We are creating CSV map like this. Let's take a look at the file I want to send. So my file looks like this. So I have, let's say that index 0 is ID. So this will be ID, this will be description, and this will be order date. So let's take a look. So here I'm parsing the file. I'm configuring the CSV reader to use comma as delimiter, no header record, I don't have any, and use this CSV map. And here again we are using domain-driven design. We map this file into order DTO, and then using again automapper to convert this order DTO into the order domain model. And we return it, and after we save it, for example, or do whatever we have to do. So here is the file watcher service. And the last one, and I want to discuss, is health check. There is very many ways we can do health checks. Here I'm just showing you how to send GET request to the any web applications, for example. So let's take a look. And the worker class again. Here, as usually, we're implementing overriding start async, execute async, and stop async as before. And here in the execute async, we are starting to implement exception handling. And exception handling is actually quite easy stuff to do if you know the basics. And the rules are quite easy there. You have actually 2 rules, not actually 3. The one is catch exceptions on the topmost level. The second one, catch exceptions on the lowest level. And the third one, do not pollute your code with try catch everywhere. So here I'm using the topmost level. So I'm catching all exceptions on the topmost level of my application. Let's take a look at the create scope and execute function. Here I'm doing another cool thing, an interesting thing. When you deal with the worker services, the most difficult part is to deal with the memory, because like it's long-running processes and it's very, very easy to get the memory leak. And my advice always to use create a scope. When you create a scope, you have to be careful how you do your dependency injection. So when you create a scope, like for this application service here, I register it as scoped. What does it mean? It means that this, when I resolve it like this, get required service, it will be shared in this scope. Just one instance of this class will be created. And when this scope is disposed after this, all dependencies will also be disposed. So all objects we created here will be disposed when we finished with the run. And then another cool guy here, this one. When you perform any heavy run, when you have to deal with the big, really big files, or have to load in the memory a lot of data, then you can ask garbage collector to instantly collect all your, and so deallocate memory. So when you're done with the run, the memory will be deallocated right away with this line of code. It's really helpful. So let's take a look what this execute method doing. Here I created some bonus material. I'm not going to discuss here, I don't have time to discuss all this, but you can take a look by yourself. The code will be available in the Azure DevOps public project and also in the GitHub. I will share the links at the end of the presentation. So what you do, you check the physical memory, you can check the CPU, you can check the drives for free space. But what I'm going to show is how to execute this request. And here I'm just define the URL. It can be just many URLs, but here I'm just pinging my block. And you execute. And after execution, you're just checking the status code. And if status code is not good, then you log the error. So let's run the code and take a look. Yes, and let's say a couple of words about logger. Logger by default logs to your, where is this? Here. Logs to your console window. But when you're in production or on the server, you don't have this console window. Here you see the application started. You see the physical memory is in use, 34%. We can check, it's correct. CPU is 96, a little bit less now. And free space on my C drive is 24%. It means I can probably soon has to clean up a little bit of my PC. The same logs, the same information you can also find in the event viewer. So let's take a look at the event viewer in the application. Here you see application message started. So you have all these messages also arrived here. And event viewer is good, but it's not that good for your production environment. When you are in production, you have to analyze your errors and warnings and all the logging. You have to create some kind of dashboards, and event viewer is not that easy to create dashboard from. So the solution to that is to use application insights. And to use application insights in the worker services is very, very easy. You just install one NuGet package, Microsoft Application Insights Worker Service, and you add your instrumentation key in the app settings JSON file like this. And in the program, you have to say these 2 lines of code. This one will logs everything this logger logs into application insights, and another one, telemetry initializer. This one is nice one. You just define the role name, and all your components which logs to the same application insights will be shown like this. And the application now in the application insights in the Azure portal, then you go to application app, and here you can see the graphical presentation of the whole your system and even your dependencies. Here application insights find that I'm pinging my block. If you have any databases or like Azure servers, everything will be shown here. And also all your logs, if you go to transaction search and refresh, and you see all your logs will be here with all details and all information you need. Really cool. And based on that, you can create your dashboards, and you can even create some alerts, like if some errors happen, then you will receive the message or SMS or whatever. It's really powerful tool. And now, yes, and now I can back to the slides. Here you have the links I mentioned. So homepage for the Worker service is like here. I created Azure DevOps project with all this code I showed now in here. You can just go. The public project in Azure DevOps means that everyone can access it. Everyone can take a look at the code and download it. And also I created all these 3 repositories in the GitHub account. If you go on this link, you will find it there. And now I think I'm ready with done with my presentation. Thank you, everyone. Do you have any questions?
Yes, we got one question from Øystein. Why would you use worker services over Azure Functions?
Because we are on-prem, we can't use Azure Functions, so we have to use something else. But yes, if you are in Azure, then it's probably better to use Azure Functions or Lambda functions if you are using Amazon.
Okay, thanks.
So it will be even cheaper to use Azure Functions.
Do we have any more questions, either for Sergey or Sara? Oh, I guess not, but you are probably free to contact them if you have more questions later. So, or you can contact any of us from Ananuga, and we will forward the question.
Great. Thank you so much for having us.
Yes, thank you for coming.
Oh, there's actually some more questions here.
Oh,
so let's see. Let's add this.
Did not see them. Okay, one from Morten. If you're using Kubernetes, could you still configure your servers as a worker servers, or does this apply on-prem only?
This one is difficult to answer because I don't know much about Kubernetes, so I don't know. You have to try. Try and let me know.
Good luck to them, maybe.
Good luck to everyone who are using Kubernetes, you know.
Yeah. And the one from Rune, who starts, stops, keeps alive the services?
If you're on-prem, so you're hosting your services in the like Azure, like Windows services, and then you kind of controlled by like as normal Windows services. You can stop, you can start, and you can restart like normal Windows services. If you're on Linux box, then you have to do something else. But it's like executable, so you can host it like everywhere. You can put it in the Docker image and host it everywhere, and just control it how you want to control it.
Mm-hmm. Do you have any more, Håkan?
No, I think that's basically it here.
Yeah.
So then, as we said here in the show, we need your feedback and your input because we want to make this meetups as great as possible. So please fill out our survey, and we will take all of this into account. And we want to thank Sara and Sergey for these presentations, and we want to thank you who was tuning in and watching this show. So thank you so much, and I wish you a very good Monday evening.
Monday, Tuesday, who knows?
You have to check the calendar.
Every day feels the same.
Thank you for having us, and thank you all for watching us. Yes.
Yes.
Thanks so much. Bye.
Thank you. Bye.
Bye-bye.